Hello, and welcome to our presentation. This is to present our prototype that shows an alternative cooling system that we hope it could help a lot of families. Throughout this presentation, these are the main points my colleagues and I are going to discuss later on. I think even though we all know the air conditioner has been around for decades now, millions and millions of people are still suffering in the ever increasing heat. Hence, it was a top priority to think of solving such a great issue. To briefly describe this invention, we have built an alternative cooling system specifically aimed at poorer families living in hotter climates that can't afford the luxury of buying an air conditioner. Our simple, easy to make at home design utilizes cheap everyday items, such as small electric fans and ice, to aid these families in getting through the summer with its increasingly unbearable heat. Considering the mechanism of this invention, our design consists of an electric fan with porous plastic water bottles attached to the front. The bottles are filled with ice, and the entire setup is then inserted into an insulating cardboard box. Once turned on, the fan propels air towards the ice, which cools it rapidly. The cooler air is then directed through tubes, cooling the entire room by creating convection currents. The use of an insulating material to house the ice means that this setup can operate for several hours at a time. And now, I leave you with a quite short video that shows exactly how it works.
So this is the fan with the bottles attached, and these bottles they have ice inside all the way through. And this is the cardboard box, and then all we have to do is to open the box and then insert the fan inside. And then we open the fan, close it, and then this shows the air coming outside. And this was a thermometer that was measuring the room temperature now, and it's recording 29 29:30. And so we left this thermometer working here for an hour, and same for the fan, and then I'll be back in an hour. It's been here for an hour now, and now it's 25. Yes, it's almost 25, and before it was from 29 to 30, which makes around 5 degrees Celsius. And this is the fan working till now. And that's it. Below here it shows that this part of the ice has melted, but all of this is still there. So in an hour, only a small portion of the ice has melted. And that's it. That was our prototype.
The prime features of our design includes having the ability to easily construct it at home using everyday household items. Also, not only are its initial parts relatively cheap, but also it operates at low energy costs. And most importantly, it's capable of decreasing the ambient temperature in a 3 by 3 meter square room by at least 5 degrees Celsius in just an hour, as previously shown in the video.
In order to complete our project, we went through a sequence of key steps. Step 1: brainstorming possible ideas and data gathering for the design. Step 2, developing a 3D model to visualize our thoughts clearly. Step 3, selecting the most suitable materials to use in our project. Step 4, the building and assembly of our prototype. And step 5, conducting tests to ensure its effectiveness. Brainstorming. Using the techniques and skills we learned throughout the course, we managed to come up with a good sum of ideas through visual diagrams, tables, and matrices. These techniques helped us in choosing the best solution among all considered. In our attempt to make the project, we decided to search for the causes of the increasingly high summer temperatures globally, and in some countries specifically. After extensive research, the main cause we concluded is global warming, which is mainly due to the increase in carbon dioxide emissions in recent decades, particularly due to the burning of fossil fuels as an energy source. In the next two graphs, you can see a clear exponential increase in carbon dioxide emissions in recent years. This increase directly correlates with the increase in temperatures that can be seen from 1880 to 2020 in this graph. Our research also showed that an air conditioner isn't affordable for most people due to its high initial cost as well as the running cost of electricity and maintenance. It came up that the hottest countries are also the poorest ones, which means the people most in need can't afford an AC, which is why we decided to make our more affordable cooling system for these people. More data showed that hot weather has a negative effect on the individual's health as well. See, the risk factors of hot weather include heat exhaustion, heat cramps, heat stroke, hyperthermia, and dehydration, which are all very serious.
At the beginning phases of the project, we decided that we have to model 3D designs to help us visualize what idea is better than the other. Using the famous modeling engine, Blender, we were able to model many 3D designs until we settled on one, which is this one. We had to also make a proper and suitable selection of materials to suit our design. These materials included an electric fan, ice, rope or string, a box made of insulating material, and finally, a power outlet. Each one of these components have its specific purpose. For instance, the electric fan creates an air current to spread the cold air across the room. Plastic containers, they are responsible for holding the ice. Ropes, they are used to attach the plastic containers to the back of the fan. The insulating box, a foam or cardboard box, used to insulate the ice fan cooling system to increase the time for the ice to melt. Source of electricity or the power outlet. This is the main source of power for the fan. To assemble the prototype, we followed a few steps. First, we cut suitable openings in the box. Second, we filled the plastic containers with ice. Third, we placed the electric fan in the box. Fourth and last, we tied the containers to the fan. Following the previous steps, we managed to fully build the prototype based on the 3D model as shown in this picture.
In order to settle on the best design for our prototype, we decided to run several tests. We wanted to determine whether or not to cover the cooling system with a cardboard box. So we first placed the ice in front of the fan without the box and measured the time for the ice to melt and the drop in temperature. We then repeated this but with a cardboard box covering the fan and the ice. We found that the ice lasted longer and the drop in temperature was greater when the box was used. In order to come up with the best solution for our problem, we considered several alternatives. These alternatives included reducing carbon emissions, which would reduce global warming. In spite of this, we decided against it, as its results would take decades to be noticeable. Another option was building heat-resistant buildings, but we realized that insulating materials aren't durable enough to make this a viable option. In order to decide on the most suitable solution, we used the following technique. First, we constructed a fishbone diagram. Here we thought of different ways to achieve each solution. like banning deforestation to reduce global carbon emissions, heat-resistant buildings with a water cooling system, and using ice as an alternative cooling method. We created a decision matrix in which we judged our alternatives on the basis of cost effectiveness, chance of success, speed of effect, and longevity of results. Assessing the results of the fishbone diagram and the decision matrix, it was obvious that the alternative cooling system was by far the best solution. Thank you very much.